Ladies and gentlemen, good afternoon. We're very delighted and proud to be launching our Propelling the Future campaign today. Please join me in welcoming two distinguished gentlemen to the stage, Mr. Frank Hugelmeyer, the President and CEO of NMMA, and Mr. Darren Vaux, the President of ICOMIA. Thank you very much.
Well, good afternoon, everyone. Thank you for all coming out this afternoon. We're very excited, actually, about what we've got to talk to you about today. This has been a project that we've worked on for over 2 years, and the total investment in actually undertaking this project has been over €1 million. This is a serious study to look at how we, as an industry, can resolve and implement our commitment to decarbonise. Now, that's happened through the collaboration and input from our members all over the world. And that's a reflection of what our industry can do when it comes together to try and tackle some of the biggest challenges that are facing our industry, that are facing our world. In undertaking this particular project, we've then engaged and looked to see how do we tackle such an enormous challenge. And to do so, we engaged Ricardo, the international consultants, to actually undertake this exercise for us. And the reason that we did that is that they have unparalleled expertise in the field of decarbonisation, in undertaking life cycle assessments, in all sorts of fields. They're an organisation operating in 20 countries with 3,000 staff, but they have the capability and the expertise across a whole range of sectors, not just our sector, but energy, transport, aviation, defence, finance. They deal with this challenge, the challenge that we face in our sector, across the world. The reason that that's important is that the results of this report, both the data and the analysis, must have the highest integrity. And we've engaged with a consultant that has the credibility with government and industry, with policymakers who rely on the reports and information that they produce to make good decisions. So that's the fundamental reason why we've embarked on the project in this way. But the key elements with this is about collaboration. It's about bringing our industry together, it's about sharing data, and it's about tackling these challenges in a way that gives us the information that we need to make informed decisions for our future. And the reason that we've done life cycle assessment is that we need to look at the whole picture. So you will see, and you'll hear terms like well to wake, which means that we're going from essentially where the product is produced, whether it's the energy or whether it's the materials, from the source of where it's been, right through its transport, right through its manufacturing process, right through its operating phase, right through to the end of life. The process known as cradle to grave. So we are looking at the total carbon impact of a whole range of different options by looking at and working our way through that exercise. But the fundamental question is why? Why, as the marine industry, do we actually need to address this? And it's pretty simple. Because in 2016, 196 countries and other entities came together and said they were going to commit under the Paris Agreement to the reduction of CO2 to the point that they were going to reduce it by 43% by 2030. In 6 weeks, it'll be 2024. 6 years from now, there's a commitment to reduce CO2 by 43%. That's like next week. And that's the big challenge we face. The reality today is that the world is not on track to meet that commitment. What does that mean to us? It means that governments and other entities that have signed up to this commitment are now under pressure to deliver. What tool do they have? Legislation and regulation. How do you make legislation and regulation? You make it on the basis of the best available data. So our commitment in actually undertaking this process was to be able to put together the best available data with full data integrity, with full analysis integrity, so that we can use that across the world to be able to inform good decisions about how we as an industry can commit and support this process. But let's be realistic. Our industry isn't the problem. Our industry is a very, very small contributor to global CO2. 0.1% of total CO2 in the atmosphere produced annually comes from our industry. So even if we decarbonised entirely in some way tomorrow, it's not going to move the dial particularly in relation to that commitment to the Paris Agreement. However, we are still seen as a discretional industry. I don't believe that we are discretional, but we are seen as a discretional industry, and regulators see us as an easy target. And the reason they see us as an easy target is this is how most government regulators see our industry. And mostly the fault of that is us. Because when we market our industry, we're all about power. We're showing boats that are going fast. We're doing all these things. And so we're demonstrating that lifestyle through power and utilisation. So we build a perception with other people who don't know our industry that maybe that's what our industry is. But it isn't what our industry is. Our industry looks like this. And this is part of the reality as why it's worth fighting for. Because boating does enrich people's lives. The research shows that just being in, on or around water changes people's perception, changes the level of stress. We all know that. We operate in this space, we go boating and things like that, but we need to communicate that there are absolutely positive human reasons as to why boating is important. But more importantly, this is what people do. They get on their boat, they go to somewhere that they want to be, and they hang out. They go fishing, they go swimming, they just go relaxing. They're doing all those sorts of things. It's very different to that scenario of when you've got that big boat moving through the water. So, when we take those positions and we understand it, we then have to look at it and say, what is this study about? What assumptions and what's the raw data that forms the scope and interests of this study? And importantly, the scope of this study is about considering alternative propulsion systems. So we are looking to say, when we're looking at decarbonisation, we have to consider the range of different propulsion systems and energy storage systems focused on basically how we utilise different types of boats. So in that context, the scope of this report looks at a range of different systems of fuels and different systems of systems of propulsion. So we have a baseline, gasoline and diesel. We then look at sustainable fuels. We look at hybrid alternatives. We look at electric alternatives, and we look at hydrogen, both in an internal combustion engine and in a fuel cell application. We then looked at 9 different craft types. And the question is, why these 9? And the reason it is these 9 is this represents the absolute majority of the current fleet and the current production. These essentially are the representative set of boats that people use in the market today. For every single one of these boats, we've done a full life cycle assessment, cradle to grave, well to wake, which means there's been 45 separate analyses that have been undertaken for comparative purposes. Some of the interesting things in terms of, so this is the baseline data. And the thing that I wanted to point out to you about this baseline data that goes into the study is when you look at the average engine hours. So I want to pause a moment and just explain something associated with these engine hours. These are the engine hours that actually come from government sources, which are informed by the service records that are now digital across the world from the engine manufacturers and otherwise, but we're talking about data that is from EPAs and various other groups as what's recognised as to what the engine hours for different types of craft are. Coupled with that, the life of the craft. And I think there's something that we all need to recognise, is that we as an industry build an extremely durable product. And durability is actually a key component of sustainability, because we're building products that last for such a long time that they are actually enormously valuable from a sustainability point of view. So these two key points, and when you've got the majority of recreational craft that are used for less than 50 hours per year, that's not much. And so this is why part of it, the challenge in looking at an LCA analysis, is getting the balance between material sourcing, energy sourcing, manufacturing, operations, and end of life. We'll see later in when Frank goes into some of the details about the report, how all of these things actually come together and how they work on basis of these numbers. Now, what's important is that this represents the majority. So it's the majority of use cases of craft types and hours use. Of course, some people use their boats for 300 hours a year, some don't use them at all. This is the representative position that's recognised as where the bulk of the market is. So if we're looking to move the dial in relation to decarbonisation, this is the data set where the dial will move. The other thing that's important that we need to recognise is when we look at alternative systems, particularly when we're looking at electrical and when we're looking at hydrogen, there is a dramatic difference between the energy density of the storage of the energy on a vessel compared to the baseline. In simple terms, it means that diesel or liquid fuels, so whether they're sustainable fuels or whether they're fossil fuels, have a dramatically higher energy density than lithium-ion batteries or hydrogen stored under pressure. Why that's relevant is that when you try and develop options for doing it, there isn't options where you can do an apples for apples comparison on range and performance, because the vessels can't take the amount of energy of the alternative sources to deliver the full range because they become impractical. The energy storage will weigh more than the displacement of the boat can withstand. So what Ricardo have done in the preparation of this report is to come up with analysis to say what is the practical acceptability for the alternative to be considered. Now, I'm not going to try and explain to you the complexity of this graph, but what I wanted to explain to you is if you look at the baseline position on the range, the baseline position on range was that the facility would operate the vessel would operate for 14 hours and be able to do 166 nautical miles. The practical alternative that is considered within the LCA analysis can operate for 3 hours and do 35 miles. And this is in a hydrogen scenario. That's because the maximum amount of hydrogen that you can store on the vessel to be practical, to actually still be able to use the vessel for its intended purpose, limits that range. And you can see even down at the bottom of that, we talk about the implications that it has, that even then the fuel storage is still 61% larger, the mass is 13% larger, etc. It's important to remember that when we present the results, that what we're comparing is fossil fuel baseline with alternative sustainable fuels, and hybrid systems are all operating to 100% range. But the electrical alternatives that are built into the LCA effectively have about 80% less range because that's the practical limit of the technology that exists today. So we've tried to make a scenario where we can compare them fairly based on the technology that's available. And it's important to interpret the results in that way. So we move on to the results. And before we do that, I just wanted to give you an idea. This is, in fact, the illustrious €1,000,000 Ricardo report, printed on recycled paper and double-sided, importantly. Look at the size of it. Thankfully, my colleague Frank has now got the responsibility to try and interpret this in terms of its results and share that with you. But I think it is important. This is just a physical representation of the complexity of this analysis and the data set that's been built into this particular report. Tomorrow there will be a lot more information provided through the technical session, which I'll talk about a bit later. But I just wanted you to know that this has been an enormous body of work, and I'll just hand over to Frank to take us through the next stage.
Great, thanks, Darren. And as we've just heard from Darren, the Paris Agreement is critical. It's driving a lot of policy and regulation around the world. It's certainly in the U.S. As we're working with groups like the EPA, like the White House, like our Department of Transportation, the Department of Energy. In fact, right now in the United States, the administration is looking to develop, as we speak at the moment, its plan for decarbonization into 2050 for all of the different sectors, including maritime use. So the report and the timing of this report couldn't be more critical. We've also heard about those regulatory pressures that we're seeing around the world. We're seeing it where we're seeing closures in terms of taking or choosing technologies. And these are based on not necessarily data-driven decision-making within the industry. We're seeing that in California as well, where other sectors are starting to be banned and product technologies are being banned. The Ricardo is that world-leading LCA firm. And so being able to take their expertise and their knowledge of working across those sectors is going to be critical to how we explain and bring this to the market, and also most especially to the policymaker community. And our marine, as you heard from Darren, marine usage, our power, our fuel consumption, the lifespan are all unique. They're all unique to the marine environment. And lastly, I'll give you one last piece, is we're a major economic driver. We have to get this right. We cannot afford to have policymakers doing something to us that is not based on data and the best available science. In the United States alone, the marine industry, recreational boating and fishing, is a $230 billion industry. We are the primary driver of the $862 billion recreation economy in the United States. We were also one of the top drivers during COVID, where we outpaced the growth of the US economy as a whole during that time, both in jobs and in GDP growth, by 3 to 4 times. So you get this wrong, and you're going to have a major impact on the economy, on the job sector, and obviously on the future growth and success of the marine industry. So let's go to the results. And I want to share an analysis that Ricardo did to start, so you could see the detail of this report. And this is a very busy slide, but I want to go through these tasks because they're important for you to understand that the first thing they did is they looked at the decarbonization options. That was an overview of every and each propulsion system type that Darren explained, including the systems required, the impact on each craft, the infrastructure that would be needed, and the required fuel supply and other options. Task 2 was a detailed analysis of the greenhouse gas life cycle assessment, the LCA. Now, in this life cycle assessment, and I think this is critical for everyone to understand, these assessments, they were conducted to ISO standards. ISO standard 14044 and ISO standard 14067, including manufacturer, the use phase, the end-of-life phase for energy converters, as well as energy carriers. Then they went to the total cost of ownership, the purchase costs, the operational costs, including the energy and maintenance for energy converters, energy carriers, as well as any new infrastructure that would be needed. Then they looked at task 4 was the boat power systems implication, and the analysis of how the life expectancy and the maintenance requirements would change, as well as performance, safety, and commercial availability. And we heard that actually at the presentation this morning, that commercial availability is going to be a critical part of our future. And then task 6 was the suitability and ranking. Ricardo then conducted an analysis of the overall suitability of all of these different options for each craft type and use case, and Darren showed you the mix of those base cases as you saw earlier. So the key finding is that there is no one-size-fits-all in the marine industry, and good policy decision-making can't be picking winners and losers. They have to allow the innovation across the industry to move forward by use case. And this is critical because right now we have policymakers around the world making decisions based on either ideology or from what might work in other transportation sectors but won't work in a marine environment. I'll give you a couple. I'm not going to show you all of the different boat cases, but I'll give you a few just so you can start to see the trend, and then I'll show you the macro view of this. Here's a critical point of the analysis. What makes us so different compared to other markets, and particularly on land, whether it's car, auto, truck, we're much more like an airplane. We're all thrust. It takes 10 times the energy density to drive a boat through water than it does something on land. You don't also get the alternator or downhill. It's all thrust. So that energy density is absolutely critical for us to be successful as an industry and to be able to power our product. What this shows is right now, you've got 85% of the carbon impact in current cars today in the usage stage. In the marine sector, 50% of our carbon footprint is in the manufacturer, in the manufacturing stage. That's where 50%. And in fact, as you look at some of the new alternative energies, your carbon footprint actually increases compared to what it is today. So this is a surprising result that Ricardo found. And this kind of explains why. When you look at the auto industry, there's high usage, there's a lot of movement, it's being used constantly, so is trucking, so is busing, there's a high use case, an hour of usage. In boating, the majority of boats right now are sitting in a marina somewhere. Or for 7 months, they're winterized. Our usage is so unique to our industry, it cannot be comparable to the transportation sector on land. It is unique to the marine environment. And this has a big impact on the results and the big impact on what is the best path for carbon reduction in the marine industry. Here's the pontoon. So now let's get to the results. And pontoon is obviously one of the largest sectors in the United States. This is a critically important slide for us to realize and recognize in the US for us to be able to reduce our carbon footprint in the United States. But if you look right now, drop-in fuel, so yellow is the baseline, so that's today in diesel fuels, gasoline. You have hybrid. Hybrid is the mix of existing fuels today as well as with electric. And let's be honest, we've been in a hybrid industry for over 2-3 decades in the marine environment. You take an example of a bass boat like Bass Pro does and many of the other kind of freshwater boats that we have in the United States, and even pontoons have a lot of a mixed hybrid solution right now. And you can see the footprint actually increases a little bit because you've got a higher build. You then go to electric, and you see a slight decrease. That gives you somewhere around a 10% reduction in your greenhouse gases if you go electric on a pontoon. Drop-in fuel, you go to sustainable fuels, and you see a 60% reduction in the greenhouse. That actually meets the Paris Accord.
It does.
Hydrogen is right around 25% in terms of reduction. So that's promising. But again, if you look at both electric and you look at hydrogen, you see an 80% reduction in range compared to the drop-in fuel, which gives you a very clear path as to what's the best path to actually, for this product, to reduce carbon and the carbon footprint. Let's go to displacement motorboat. So displacement motorboats, you can see, actually, because of its size, its annual utilization being 48 hours, and the lifespan being 45 years. And again, I want to reinforce, sustainable products are built for a long time. We're not a fast turnover product in the life cycle. And so when you start to look at the electric side, the size of the battery alone and the carbon footprint of that battery would be so enormous just to get to 80%, a 20% of performance of what is existing. If you made that even bigger, if we actually had apples to apples in range, this would be enormous. You're seeing that you'd have an 80% increase in carbon on the larger yachts going all all electric. Drop-in fuels still meet the Paris Accords at 40%. We go to sailing yachts, and this was a surprise. When I saw the results for the first time, I was pretty surprised by this. I expected the EV sector to actually do much better in this particular version, but what happens is the usage on sailing yachts is incredibly low. The build is all, as we have already shown you, is in the manufacturer. The footprint is in the manufacturer. So if all of a sudden you're putting in a larger battery within that space that has a larger carbon footprint, you're going to see it increase. And so you see that in hybrid, you see it in electric. Now, you still may want to use that product for a wide variety of other reasons on that, but you cannot be saying that you're reducing the environmental footprint of that product. The path forward on this, again, is the drop-in fuel, sustainable fuels at 30% improvement. High-performance motor yachts, and this is a really a pretty compelling story right here. This is where you start to get on plane, right? So high-performance or planing-type yachts, obviously one of the largest sectors within the marine industry in the U.S. Drop-in fuels have a 90% reduction. This is the largest impact that we could have on the industry out of all the other sectors and all the other products, as you'll see. So you put in sustainable fuels and get net neutral in that area, and all of a sudden we've had a major impact on our footprint as an industry. You see a slight improvement in hybrid, so there is some improvement, but it's only about 10%. You see the same thing in electric. You have about 40%, so we're meeting the Paris Accords on this front with electric, but you've lost 80% of your performance. So until we see some sort of battery moonshot to say we're not really going to see this turn into the path forward for us to really decarbonize, because you've lost so much of the performance of the overall product. And the same is with the hydrogen. So those are early stage development technologies, and we need to recognize that they're early stage technologies, and that's where they are at this stage. PwC, so this was the one area where electric performed well. And I want to make it very clear that this was a rental analysis. So this is a commercial analysis where you're seeing the annual utilization at 156 hours. So, and a shorter lifespan at 12 hours. If you had a PwC and you owned it, you would see this change quite considerably, because you'd probably have to replace the battery after 12 years in this case, and the annual utilization would be much down. And we don't have those numbers, but we wanted to make sure that Ricardo showed what would be high use case. So smaller size footprint boats, obviously, and Torqeedo's made a great business of that, and they're a great example of use cases where electric makes a lot of sense. And particularly in the rental side of the industry where you have high utilization, we're going to be able to see a variety of different technologies provide that improvement, but you still have performance limitations that have not changed. What you still see is the drop-in fuel continues to be really strong in this case. So basically, if you look at the overall results of all of these findings, the one thing that comes across all of this is the clear path forward for decarbonization within the marine industry is going through the sustainable fuel lens. This is a critical point, because we, in the US, we'll just give an example, this not only serves the market going forward until 2035, which is really where Ricardo forecasted this out, but we have 12 million boats in the United States that are already in the fleet. And if we can put the sustainable fuels in the existing fleet, we not only get this type of performance and reduction across new boats, but we reduce the footprint of the existing fleet by 30% immediately. And if we do that globally, we have 30 million boats estimated around the world. We immediately reduce our carbon footprint by 30%, just through the sustainable fuel distribution strategy. That is the best path forward for us to be working with policymakers globally and around the world. And we're certainly moving in that direction based on these results in the US. We're changing our policy positions in the US to prioritize sustainable fuels. We're highlighting we really need more R&D in the electrification sector, and particularly around batteries. And we need safety standards in both hydrogen and in battery technologies because they don't exist. And that really is where we need the focus of policymakers, both at the state level, Canada, as well as in the US. I think that's my last slide, so I'll hand it over to my partner in crime here.
So, how do we distill this down into a framework that can be used for guidance to policymakers? And I think, as Frank said before, there is no one size that fits all. Boating is unique, boating case and use studies are unique, the craft are unique, and so we need to basically look at each use case to find the most applicable outcome. But one thing that's become very clear from the Ricardo report is that undertaking the LCA analysis is absolutely fundamental to actually understanding the true carbon footprint of the alternatives. You can't ignore the energy source, you can't ignore the material source, you can't ignore the manufacturing process. You have to look at that because it's such a significant part of the equation when we're looking at the total carbon footprint of each alternative.
Yeah, and Darren, I'll add that if you do ignore that piece, you might, in some of the alternative energy sectors, be ignoring the majority of your carbon footprint.
Absolutely. And in fact, upfronting the majority of your carbon footprint as well. But I think the reality of this, the conclusion that comes from the analysis, is that if we have a commitment to actually deliver our industry's participation in meeting the Paris Agreement, then sustainable fuels are the leading path for us to meet that Paris Agreement. For both the existing, and this is a really important part, as Frank said, looking at the US figures, 12.5 million boats in the US, 250,000 new boats sold each year, average life of the existing fleet more than 20 years. We've got 6 years to meet the Paris Agreement. We need policymakers to focus on providing a supply chain for sustainable fuels, because that is the only way that our industry will actually meet those obligations. The current technologies around electrical, particularly in relation to the energy storage side of it, because of the energy storage side for both electric and hydrogen, the energy density side provides such limitations, and in the current supply chain manufacturing processes, for the majority of cases, not in all cases, but in the majority of cases, the carbon embodied within the supply chain to deliver those outcomes is significant to the point where it can't be offset during the use phase, which is why the figures show that some of these alternatives, even operating at 80% reduction in range, still have a higher total carbon footprint than drop-in fuels, sustainable fuels. So what does this mean? We need to have more R&D and technological advancement in that. As Frank said before, we need that moonshot in relation to energy density for storage of those elements, particularly in relation to electrical. But at the same time, we need global safety standards. We need standards to actually catch up as they often lag. Because these technologies are emerging so quickly, we can't forget that the process associated with safety and infrastructure and all those things have to be considered in parallel. So the reality of this is we need to have policymakers focused on the supply chain for sustainable fuels. We need their support to look at technological development ongoing in relation to these alternatives. And all of this needs to be considered in the context that every use case is unique. There will be suppliers who have addressed the supply chain issues in relation to their product, which provides them with a unique opportunity to actually address the problems that have been identified. And this report isn't about discouraging. In fact, we want to support them to achieve these outcomes. I want to be really clear, this isn't about discouraging effort in that regard. And the reason that this report's important, though, is that this deals with the majority of the marketplace, the majority of the manufacturing processes, the majority of the products that people use. And as a consequence, we need to have a solution both for the existing fleet and new products that can guide policymakers in what steps they need to take to support us on our journey to meet the obligations under the Paris Agreement. So this is the overall summary. But this is just the start of the process. We can't distill 558 pages, printed on recycled paper, double side. We can't distill that down into a half-an-hour presentation. We can't distill 2 years of work by technical experts that we are not, but what we've tried to do is to distill it in a way through communicating with them to be able to provide you the framework that we have the obligation to address, and that is how do we interface with policymakers to give them the best information they can possibly have to make the right decisions as to how our industry can decarbonise in consistency with the Paris Agreement. Great experts with Ricardo. We have a data set, a report, data integrity analysis that's been peer reviewed by 3 separate parties. One of them we engaged was a devil's advocate. Give us every possible vulnerability that this data set has, because we wanted to test it. It's so important to us as a group that we can that we can provide this report to our members, that we can provide it to governments around the world, and they can look at it and rely on it to make informed decisions. And so that's why it has been so important. So over the next coming days, tomorrow, there'll be a session where we have our technical leads that will be available to drill down into more detail about this. But this is just the start. This process will go on for a long time, and there is a lot more work to be done. But I think it's pretty clear that it's led us to a certain point and a certain step. That's it. Thank you.